Good morning, people. This is assignment number 8 for the morning session. So the problem that we have is something from a past midterm or final, and it is showing the following mechanism. So we have this piece that is translating along the yellow base and is also rotating about its axis. Now, the information that's given to you is the speed, the linear translational speed of or position of the gray piece is given by what is indicated here. So you take any point on it, the position of it is given by this, as it starts to move, the position of it as a function of time is given like that, and the rotation of it, the angular rotation of it as a function of time is given by the curve that you see here. Now notice that the breakpoints of these are different. The example that I did in class, whatever things changed here also changed down there. That is not the case there. And I mentioned that it is easier to do problems of this type where the breakpoints are different, as indicating two rules governing the motion of this mechanism instead of a single rule. Because if you try to do it as a single rule, there'll be a lot of if statement, if things is between 0 and 5, if things are between 5 and 6, etc., etc. The other thing is that notice I'm asking you to plate the trace here, the trace of a point, the center of this, for example. By the way, using your own dimensions. Now that trace will depend on how fast these things are moving. Now, everything that we have done before, or at least most of the mechanisms that we have dealt before that I asked you to plot the trace, was a single degree of freedom system. In other words, it didn't matter how fast things happened. A particular point that I wanted the trace of always followed the same thing. But this is not a single degree of freedom system. It's a 2 degree of freedom system where the two are tied through these rules, and the trace of a point on it will actually depend on these rules. Okay, so before you can run 3, before you can get information about 3, you must be doing simulation with laws, and these are the laws that you're going to be uh, using, and that's the main difference. Okay, so let me go ahead and start with my product. There we are. I save it, file, save management. I'll call it morning. Your desktop. Where is this? Desktop, new folder, and I'll call this thing homework 8. Homework 8, morning. Okay. So first I'm going to insert the base, insert a new part in there. I'll call it the base. On that vertical plane, I will sketch. I'll draw a rectangle here, centered rectangle. Okay, now I'm going to draw a little circle here. This is going to be basically the shaft. Let's do a cleanup, so quick trim. I'm going to get rid of this, and I'm going to get rid of that. Oops. Let's do another one. Okay, there we are. Exit, pad it. Okay, just make it so that it looks kind of what I have there is, yeah, okay, I'm going to make it like that. All right. And then I'm going to insert the second part, which is called the shaft. I'll call it the moving part. How about that? So insert a new part, right click properties, moving, so moving part, moving. Okay, let's go make it. Double click on this. On a convenient plane, on that same plane in the back, for example, I will sketch. By the way, this base looks a little bit different from what you have because you have a, this end is closed, but it really doesn't matter. I'll just leave it the way it is, okay? So sketch, and I'm going to project that circle, or the other option is draw a circle. I can project it. Sure, yeah, why not? I project. There we are. And now I'm going to close that circle. And how I'm going to do that is going to be maybe an arc right there. This is coincident with that center. Oops, something like that. This control that, close it. Coincident, okay? Okay, exit. And I'm going to pad this. Okay, good. And just so that it looks, the end looks like that, I'm going to clean it up a little bit. So on that face, I'm going to draw a circle, concentric circle. And these don't look coincident, concentric. So let me do them. Two concentrics. This control that, and we make it concentric. Okay, good. And why don't we draw a little circle here? That will be the hole that you see in the figure on the top. Yeah, that's good. Exit. Pad it. Okay, by a tiny amount, maybe maybe 0.2. Let's see, point 1. Let's see how it looks like. Yeah, that's good. Okay, very good. Now, while I'm here, I'm going to create a point there because we want to draw the trace of the center of this. So I make a point, center of a circle, and this is the circle. Good. Okay. And now let's go save everything. File. Oh, go all the way to the top. Click on the floppy. Oh, you can change the color and things like that. That's really irrelevant. I'm not going to do that. Now, we go to assembly design, fix the base, anchor the base. Now, there's going to be a prismatic joint. This is going to move. Okay, wait a minute. You know what we can do? If we make a cylindrical joint here, then we can control is lengthwise motion and rotation. Okay, or obviously I can make a prismatic and a cylindrical. That's not necessary. Anyway, there are other ways of doing it. I'll make a cylindrical joint. So coincidence between this axis and the axis of this cavity. Okay, and that's pretty much it. So let's bring this thing into the show mode. So this is a cylindrical joint. I can control its rotation and I can control its translation. Okay, very good. So now we're going to go to a digital markup, DMU kinematics, get the magic wand out. You will see that new mechanism 1, auto create, and there will be a single cylindrical joint with 2 degrees of freedom. Right there. Okay. Now, first of all, in order to be able to control the lateral motion and rotation, I'll double click on this. make this thing angle driven and length driven. Okay, so I'm going to create rules for both of them. The only thing is that I don't want this thing to go in that direction, so I flip it so that it goes in the other direction. That was a blue arrow. See this blue arrow? So that's fine. Okay, good. I know that the mechanism can be simulated. That much I know for sure. Okay, so let's do the following. Remember, we have to put these laws into the CATIA program. So what we're going to do is to go start. Where is that? KnowledgeWare. Okay, and then there's going to be Knowledge Advisor. This is where we create our rules. I'm going to do two rules, one for translation, the other one for rotation. Let me start the translation first. Click on this. I'll call this thing translation. Rule 1 is for translation. Translation. Okay. Say okay. Good. So if you click on the mechanism, you get only the stuff related to the mechanism. But in this rule, all I want is this length. So here's what we're going to do. You're going to say if time less than, let's check it out, less than 6, okay, less than 6 seconds, oops, where is that? Do not forget the S, 6S, enter. Then the rule is, the speed of this thing is 5 inches over 6 seconds, 5 over 6, okay? So we're going to go here, we're going to say equal to, oh, sorry, enter, this length equal to, parentheses, 5 inches over 6 seconds times time. And there's time. Enter. And then it's else if. Okay? Else if, or if you don't remember, just click on the keyword. There is else if. Okay, go back to parameters. Else if time is less than, let's look at this, less than 8 seconds, 8 seconds, 8 seconds, enter. The length, not this, the length, this command, okay, equal to, now remember, it's sitting at the location 5 inches, right? It's sitting at location 5 inches, and it has to go to the left now. So 5, see that? 5 negative that slope times time. Okay, so we go here, and don't forget the shift, by the way. So it's going to be 5 inches, 5 inches, negative 5 inches divided, I think it was 2 seconds, right? If you look at the figure, you see 2 seconds there. Right there, 2 seconds. Okay. Times, parentheses, times, minus the shift. And the shift is 6 seconds. Minus 6 seconds. If you don't get it, please sit down and think about it, okay? Don't just copy what I'm doing, because that's going to cause you a problem. And then what happens is that in the third stage, if time is less than 10, so we go here, else if, keyword, right? Keyword, else if, times is less than, actually this last one is the last stage, so I don't really have to do else if, I just say else, okay? I don't have to do else if, because that's the last stage, right? Else, that means obviously it's bigger than 8, So enter length equal to now if you look at this figure, it is at position 0, distance 0 at 8 seconds at 0, and then it builds up speed again to the right, and it's going to be 4 inches over 2 seconds. Okay, so it's going to be 0 inches. I'll just type it so that you can see why we got that. 4 inches over 2 seconds, okay, times parentheses, don't forget the shift, time minus 8 seconds. Oops, 8 seconds. Okay, so hopefully I didn't make any mistakes here. There are no syntax error, etc. If I say okay, if there are no syntax error, it closes. Yep, good. There is a first law, translation. And then I click on that icon again, and I say rotation. And I go through the same shebang. Unfortunately, there is no cut and paste, so we have to go and type everything once again. But of course, the breakpoints are different. So if time is less than 5 seconds, it goes 90 degrees in 5 seconds. If time is less than 5, so if time, let me click on that so that it filters it. If time is less than 5 seconds, the angle equal to what did I say? 90 degrees, parentheses, 90 degrees over, what was that? 5 seconds? No. 5 seconds times time. Else, if, again, time. Next breakpoint is going to be 9 seconds, right? 9 seconds. Less than 9 seconds. By next breakpoint, I mean this. 9 seconds. Enter. Angle equal to. Now let's see, where does it start from? It starts from 360 degrees, right? 360 degrees. Oh, wait a minute, no, I'm sorry. Just a second. This is starts at 90, right? Starts at 90 and then builds up. So that is 270 degrees in 4 seconds. Okay, so it starts at 90 degrees. You have to be very careful here. 90 degrees plus 270 degrees divided by, let me see, 270 degrees. This is 270 degrees over a 4 second interval. Over a 4 second interval. Over a 4 second interval. What's going on here? Right there. Yeah. Divided by 4 seconds times parentheses time minus 9 not 9 minus 5 seconds. I mean, obviously, if you type the wrong stuff, when you plot this, it's going to show up 5 seconds. Okay. And finally, else, here is the time. Here is the angle equal to. It starts at 360 degrees minus, because it goes down. You see that the slope of this line is negative and it's going to be 360 degrees over 1 second interval. So minus 360 degrees DEG divided by 1 second times parentheses. There's your time, and the breakpoint is minus 9 seconds. Okay. Once again, if I didn't make any mistakes here, this should not give me any syntax error, and it didn't. Okay, very good. So now we're going to go and do a simulation with laws. So we go here. Obviously, we are not in the right spot here. We have to go to DMU. Just double click on this, it'll take you there. You are in DMU. And get the simulation with laws right there. Okay. Oh, we need a sensor, right? Now, I want to remind you that the two commands here, although yes, I do need a sensor, so let me go ahead actually and do that. So I'm going to go create a sensor. So the reference is that base, and the point that I want is that point. Okay, good. Then we're going to go simulation with laws, activate sensor. All I need are these two command joint commands. Okay. Now I'm not asking for the velocity of this point in the x direction or y direction or the acceleration. All I want to do is to plot these two, make sure that it's exactly what I entered, because otherwise things are wrong, right? Let me see. Am I asking for something here beside that? Oh yeah, okay, I suppose I want magnitude of linear velocity. Okay, we do want it. Okay, but first let me check my work. First, let me check my work. Before I do plot these things, let me check my work. Okay, in other words, if the two plots that I get here based on these two is not right, then obviously whatever I do after that is nonsense. Now, good. So we say play it. We play it. Okay. Good. And graph it. This is these two. It better be. Otherwise, I made a mistake. I'm pretty sure they are. Okay. Now that I know that this is fine, I don't need this. This is a confirmation for you that you did everything correctly. You rewind, clear the history, and then you say, okay, what do I want here? I want selection. You were asked to plot two things. You were asked to plot. I haven't done the trace yet. I will do that. Okay, let me actually do the trace. Let me actually do the trace, and then we're gonna. While we are at it, we might as well do this. Okay, so plot the magnitude of the velocity, linear velocity, and magnitude of two things. Magnitude of the linear velocity. Let's do this one. Magnitude of the linear velocity as a function of time, obviously. So magnitude of linear velocity, let me uncheck these two because I know these were correct, right? So magnitude of linear velocity is the same as linear speed, okay? And it's going to be as a function of time. So we play it, the history is clear, you can see that. You play it and you graph it. Okay, first make sure that you have zoomed out so that I can see your units here. Okay, good. And then remember how we do these things. We print screen, start a Word document, paste it. Did I not do print screen? Let's try it again. Print screen, start the Word document. Let me see. My print screen. That's interesting. But again, oh, I was hitting page up, sorry. So let's start the Word document. Paste, home paste, there. And save this thing. File, save as, desktop. Where's my desktop? It was in this folder, homework. No, let me see. I called it July something. July homework 8 morning. That's where it is. So my first plot is linear speed versus time. Okay, and this is one of the folders you're going to have to be submitting if this was a final exam problem. Let me kill that. Now, the second part, look at the second part is this. The second part of the problem says, or this part says, magnitude of the linear velocity that we just plotted against the magnitude of the linear acceleration. So what we have to do here, notice that I did not ask for the magnitude of the linear acceleration. So first of all, I'm going to rewind. I'm going to clear the history. On the selection, we already asked for linear speed right here. Magnitude of the linear acceleration is right there. We asked for it. Okay, move this thing out of the way. We play it. Okay, under options, we ask for customize plot. Add. It says, what do you want? I want the linear speed that I asked for versus the linear acceleration that I asked for. Where's the linear acceleration? Right there. And then I say OK. And yeah, graph it. There. Again, zoom out. Linear speed versus linear acceleration. Okay. And once again, print screen. Start the Word document. Paste it. Well, that's not the right one. Delete. Let's go back here. Print screen. Print screen once again. I press the page up over here. Home paste. Save it. File. Save as. Save as. In that folder, which was, I believe it was here. Yep. And I'm going to call this thing linear speed versus linear acceleration. Okay, save. I can close this. I can close this, rewind, say OK, and close. What is the part that I have not done? Right here, generate the trace of this. Okay. Okay, the main difference between what we have to do now and what we did for generating trace before is the fact that here we have some rules specified, okay? And the trace depends on these rules. Anything that we have generated in the past was a single degree of freedom mechanism, and it really didn't matter how fast this thing moved. It always gave that point, always gave the same trace. But here, that's different. So you have to do the trace in a different ways. Here's what we're going to do. We're going to click on trace, and it's going to come back and say, okay, I didn't even bother generating a mechanism and or a simulation replay. I just say, look, trace, clicked on the trace, select mechanism one. There's only one mechanism here, and says element to trace out is this point, and reference product is that's fine, product or the base. It doesn't matter. Okay, and then we say okay. There we are. You see. Now, in the past, what we did, we first created the simulation, then compiled that simulation, okay, and then we can go and plot the trace. But here, we don't do that. We just directly click on that thing which said trace and select the mechanism, okay. If it's already selected, that's fine, and then pick the point and say okay, and it's going to do that. The rest of the stuff is the same. So you go to File, Save Management, trace is going to be in that folder. Remember, base, moving, and remember there are two files in there too. Looks like I have deleted them. One of them was Word document which I used to plot the what is that? Velocity versus time. The other one is velocity versus acceleration. And it looks like I either put it in the wrong spot or let me actually see. Oh, if you say all, I'm pretty sure you're going to see it. Right now, it just said, just show me the cat part. I bet it's going to be there, but right now we don't see it. So we say my trace, save it in there, and okay. And I bet if you went to that folder, you're going to see those things too. So let me see now. What was it called? Homework 8, right? Desktop, homework 8. It must be somewhere. Now these things are important when you do this for your final exam. Let me see. Oh, there it is, right here. You see that? They're there. And this is the trace that you just put in there. Now, if you go to CATIA, we can close this, and then we can say insert existing component in there, and there is a trace. It's the wrong folder. We go up, desktop, homework 8, right there, trace 3. You say okay, and you're going to see that right there. And in fact, if you play it, if you do, for example, simulation with laws, and just say play it, that point is going to go through this path that you see. Okay? It's right there, right now. It's kind of hard to track it down unless you go at you do it one by one. You can see that. You see this? See that point is turning? See this? You see? Let me make this thing maybe 3. There. Where is it? Right now it's this location, right there. Okay, so that takes care of this homework.